Alright, so for our last one, we are going to prove that sine of theta over 1 minus cosine of theta equals 1 plus cosine of theta over sine of theta. So on the previous two examples, it was pretty clear that the left side was more complicated than the right side. Wasn't there more stuff on the left side if you look back? Definitely this is more complicated than that. So that's why we started on that side. This was more complicated than that. This one, they're equally complicated or less complicated, whatever you decide. So you can start on either side. Okay, so really we want to try to start on the more complicated side if the one side is more complicated. But it's not, so you have a choice. And the proof would be similar going through each side. It would take the same number of steps. I'll start on the left. I don't know, or do you want me to start on the right?
Left.
Alright. So here's the deal. I have to try to get this sine, or this 1 minus cosine on the bottom, to be a sine on the bottom. The only way I know how to do that is 1 minus cosine. You can't just flip it. You can't, because think about this. 1/3 is not the same as 3, so you can't just flip a fraction. They're not identical. But I do know that 1 minus cosine squared is sine squared, correct?
Yeah.
Wouldn't that get me a little bit closer? Okay, so here's what I'm going to do. I'm going to use my strategy that was actually given to you before, but I'm going to make it up myself. I am going to multiply top and bottom by 1 plus cosine theta. And my goal here is to get a Pythagorean identity. Okay. So let's, I haven't done anything, by the way, just I decided to multiply the top and bottom of a fraction by something. So on the top, and you can choose to distribute, it's not going to give me a Pythagorean identity, so I'm going to hold off. For now, I'm going to just write this. 1 plus cos theta times sine of theta is on the top, right? What's on the bottom? Remember our whole goal is to get Pythagorean identity. Isn't it 1 minus cosine squared? Okay. Alright, so I haven't done anything except multiply the top and bottom of a fraction by the same expression. That's not trig. Now I'm going to use my Pythagorean identity. What is 1 minus cosine squared same as? Sine squared. So on the top, I'm going to leave this, and you're going to see why in a second. Why I'm not distributing it. You can distribute it, it's just a little more difficult to see. Alright, so now I'm going to write that this was a Pythagorean identity. I'm really close. Remember, this is what I want it to equal. Can't you take a factor of sine out of the numerator and denominator? So if I take a sine out of here and one sine out of here, because sine squared is sine times sine, right? Then, and I just simplified, I'm left with 1 plus cosine theta over sine of theta. Wasn't that what I was trying to prove?